Hello and welcome to Algebra. Today, now that we've seen what linear versus exponential is, we want to look and see in a little bit more depth what exponential functions are and how we can actually use them, apply them in some different situations. So let's begin. Remember, linear form is in the form y equals mx plus b, where exponential form y equals a times b to the x. So this is going to be something multiplied by itself over and over again. All right, evaluate each function for the given value. You might ask, why do we have g to the t? A lot of the function values that you see are f of x. That means that x was your input and f was your output. Basically what happens, you just change the letters around. They can mean different things in different situations. G could be golf balls, T could mean trips to the green. It just depends on what you're looking at in the given situation. Just remember that the one in parentheses is what's being put in, and the one that's out of the parentheses is what's coming out. So you can think of it as your traditional x and y values. So in this case, what we want to do, we want to plug in -2 for t, and then just see what happens. So t is -2, and everywhere you see that t, we're going to plug in -2, so in both of these places. Now this we just keep as is. We need to follow the order of operations here. Now I see this as 4/10. Notice 4/10 could be reduced to 2/5. Now because I see this negative exponent, I'm thinking I could flip a fraction, which would make it a lot easier to deal with. So I'm going to put it in the form 2/5. And then flip this fraction upside down. So the negative applies to the 2. If you followed our algebra course, then you know that Chuck Norris is going to flip it upside down. And so 2 to the -2nd, Chuck down, 5 to the -2nd boots him up to the top. And so now we're going to continue to evaluate 2 times, that's 5 squared over 2 squared. That's 25/4, and I'm going to put this over 1 because I have this in this form. I have two fractions. We have multiplication. I can reduce that fraction, and we get g of -2 equals, you could have it both ways, 25/2, or you could say 12 1/2. Either form would be fine. And that's what we're going to do to evaluate. You plug in the value for the variable, and then you just evaluate to see what happens. Of course, use your order of operations. So in this situation, we have one of the traditional exponential function situations that actually applies is in exponential growth. So in certain populations, you see exponential growth. Usually it's something like, of course in this case, foxes, flies, insects, that sort of thing. But anyway, so what we're going to do is, what's important in any of these is to look at the question. What are they asking for? So how many foxes will there be after 45 years? So now let's go back through the question. Anything that's relevant to that is important. Anything that's not pertaining to that, relevant to that, that answers that question, we just throw it out. It's no good. So population of 75 foxes in a wildlife reserve quadruples every 15 years. So this function here, x is the number of 15-year periods, so that's going to be important. X is not just years, it's 15-year periods, models of population growth. So we're going to look at this question in terms of the 15-year periods. That really stood out in my mind. So 45 years, that's 3 15-year periods, so x is going to be 3. So you have to make sure you're looking in context how you answer that question. So y equals 75 times 4 to the third, and now we're going to see if we can answer this question. How many foxes will there be? Well, y equals 75 times 4 to the third is 4 times 4 is 16, times 4 is 64. And we're going to multiply this through. Y equals 4,800. So how many foxes will there be after 45 years? I'm going to say after. Of course, anytime they ask in words, it's best to answer in words. After 45 years, there will be 4,800, and I'm going to say about because this is an estimate. 4,800 foxes, and that's it. So after 45 years, there will be about 4,800 foxes.